Hi, Algebra 1 students. This is Mrs. Mayer, and today we're going to continue talking about literal equations. So, just as a reminder, literal equations are equations that have two or more variables and an equal sign. So, if it says solve the literal equation for x, that means to get x alone. Okay? So, like we would approach any other equation, we want to get everything away from the x. And what's going to be different is we're not going to be able to simplify everything that we move. So to move the 2 and to move the p, I need to subtract them from both sides. When I bring them to the other side, it's not like terms. So this becomes z minus p equals 6x plus 2. Now I have to subtract the 2. And since the 2 isn't like terms with the z or the p, it becomes z minus p minus 2 equals 6x. And I'm running out of room here, so we have z minus p minus 2 equals 6x, and we have to divide everything by 6 to get x by itself. So you can write your final answer as z minus p minus 2 all over 6 equals x. You know you are done when x is alone on that side of the equal sign. Over here to the next example, we're still trying to get x alone, but we notice that x is on both sides here. So we have negative 5x and 8x. So I want to combine those first. So you could either subtract 8x or add 5x. And I'm left with 7y equals 13x plus 7. Now I'm going to subtract 7 from both sides. And what's really important to note here is the 7 and the 7y, they are not like terms. So I can't subtract those. So I just have to rewrite 7y minus 7 equals 13x. And now finally I'm going to divide by 13. So now I have x alone. What my final answer is 7y minus 7 over 13. Okay? When we look down here, we are now trying to solve for y in terms of x. So if it says solve for y in terms of x, that means we are now getting y by itself. So we're going to first subtract 6 from both sides. And I get negative 1/3 y equals 2 plus x minus 6. If we notice now, the 2 and the negative 6 are like terms, so we want to combine those, and we get negative 1/3 y equals x minus 4. Remember, that's where we got the negative 4 from. So here, we're not getting x by itself, we're getting y by itself. Okay, so we need to multiply both sides by the reciprocal here, which is negative 3 over 1. Now the catch here is when we multiply, we have to multiply negative 3 by everything on this side. So we are left with y equals, and I'm going to distribute this, negative 3x minus 12, plus 12, sorry. Negative times a negative is a positive. This is what's called slope-intercept form, if you've heard of that, and we're going to be using this in later units. It's going to be really helpful because we need to know how to get y by itself. Okay, over here, we are still trying to get y by itself. I have an 8x and a negative 2x. So I'm trying to get y by itself. So it would take me more steps if I moved the 2x. So I want to move everything away from the side that y is on. So I get 2y equals 9 minus 10x. Here I can divide everything by 2, and I get y equals 9 over 2 minus 10x over 2. Or I could write it all over one of those. And to simplify, it looks like 9 over 2 minus 5x. This would be my final answer. If you left your answer like this, 9 minus 10x over 2, that would be okay as well. But this more simplified answer helps us graph, but that's something we're going to be doing later. So if you can get to the yellow part, then you are going to be good to go. The next part, we're going to look at some formulas. So you might have seen these in science class, perhaps. But this is what we use literal equations to kind of manipulate formulas. So if we're looking for m here, in this case we want to divide both sides by a so that the a's cancel here, and we get f over a equals m. Over here, for the volume of a cylinder, we want to solve for h. So these are all attached by multiplication. So I can divide by pi r squared on both sides because they're both attached by multiplication. So this would be v over pi r squared equals h. And finally, we're going to end with a word problem, everyone's favorite. So we will first want to start by reading it. So the total cost C in dollars to participate in a triathlon series is given by the literal equation C equals 90x plus 35, where x is the number of triathlons in which you participate. So x is going to be the number of triathlons. So when it says solve the equation for x, that means we need to get x alone. So I'm going to rewrite our equation here. C equals 90x plus 35. In order to get x alone here, I want to subtract 35. And remember, c and 35, they're not like terms. So I'm just moving it over to this side. So c minus 35 equals 90x. And now I'm going to divide both sides by 90. So my final answer is c minus 35 over 90 equals x. Okay, where x represents the number of triathlons. So there's my equation with x by itself. Now it's asking, in how many triathlons do you participate if you spend a total of $305? Okay, and then in this one, $665. So why this is helpful is because we just moved everything over so that x is by itself. And x in this case represents the number of triathlons. So basically it's asking, in how many triathlons do you participate in if you spend a total of $305 or $665? So in this case, these values here represent C, right, which is the total cost. So for the first one, for 305, we would plug in 305 for C. So we've already manipulated this equation. So it's C minus 35 over 90, right? So I'm going to plug in 305 minus 35 divided by 90 and type that into my calculator. Once I make that calculation, I should get exactly 3. Okay, so this would be 3 triathlons. Okay, for 665, I'm going to do the same thing, except I'm going to plug in 665 for C. So if I have C minus 35 over 90, I'm going to plug in 665 minus 35 over 90 and plug that into my calculator. And I would get 7 triathlons. So this is an example of why it's helpful to use a literal equation to solve a problem. The last problem, it's saying if your maximum triathlon cost is $1,000, what is the maximum number of triathlons in which you could participate? So in this case, what we are given is we are given C again. So if my maximum cost is C equals 1,000. So I want to plug in 1,000 here. So if I get C minus 35 over 90, and I plug in, let's say, $1,000, and I do that calculation, I get 10.72 triathlons. So if I don't want to spend over $1,000, I can only run 10 triathlons.